This is the second AP problem. We're given a 0.150 gram sample of solid lead 2 nitrate is added to 125 milliliters of 0.1 molarity sodium iodide solution. We have to assume that there is no change in volume of the solution, and the chemical reaction that takes place is represented by the reaction below the problem. So for part A, we have to list an appropriate observation that provides evidence of a chemical reaction between the two compounds. So the precipitate PbI2 is formed because of a double replacement reaction. Part B, we have to calculate the number of moles of each reactant. So we're given 0.150 grams of PbNO32 is in the reaction, so we're going to divide that by its molar mass and get that there are 4.35 times 10 to the negative 4 moles of PbNO32. To find the moles of NaI, we can multiply the liters by the molarity of NaI and get that the moles of NaI is 0.0125. Part C, we have to identify the limiting reactant. So what I did to find this was use a multimole ratio to find out how much NaI would be produced if 4.35 times 10 to the negative 4 moles of PbNO32 was current, and I got that there would be less moles of NaI. So since there were originally more moles of NaI, PbNO32 is the limiting reactant. In part D, we had to calculate the molar concentration of the NO3 ions in the mixture after the reaction is complete. So to find concentration, we use molarity, and that's moles divided by liters. So 2 ions of NO3 minus are present after the equation occurs, and according to the law of conservation of matter, 4.5 times 10 to the negative 4 moles, which is present in the first part of the reaction of PbNO3, multiply that by 2 because NO3 breaks into 2 ions. And we're going to divide that by the 0.125 liters and get that the molarity is 7.25 times 10 to the negative 3. So for the last part, we had to choose the diagram that best represented the results after the reaction occurred, and this was the diagram that I selected. So I selected this one because PbI2 precipitates, and PbNO32 is the limiting reactant, so there's no excess Pb plus 2 in the solution. And there was so much NaI excess that some iodine ions are still there with the Na plus and the NO3 minus. And that's the end of the problem.